In specimen accessioning, we receive the specimen and check if all information and documents are complete. I have here the request form, which contains the patient's information, history, and description in the site of origin. This is also where we check for the serial number given. This specimen is prefixed with formalin. I will now write the details in the logbook, such as the serial number, patient information, specimen, and the name of the pathologist who will examine. I will also fill up the surgical pathology worksheet and attach all documents along with the receipt of transaction in one folder.
Hi, my name is Juvin Klein Glarain Abadasis Elid, a registered medical technologist. So today, I will be demonstrating fresh tissue preparation. But before doing any procedure in a laboratory, I have to make sure that I have my PPE. So now, I am wearing my lab gown, my gloves, my hairnet, and I also have to wear a mask, but for the purpose of being audible in this video, I will not be wearing one. So fresh tissue examination is used for rapid microscopic analysis. It has the advantage of examining tissues in its fresh state, wherein protoplasmic activity such as mitosis can be observed. However, fresh tissues are not permanent. So today, I will be performing the different methods of fresh tissue examination, which includes teasing, squashing, and undersmearing, streaking, spreading, pull apart, and imprint. I will be performing the teasing method of fresh tissue preparation. So teasing is a procedure in which a selected specimen is immersed in an isotonic solution. So these are my materials: my selected specimen, an animal liver, isotonic solution in a watch glass, dissecting needle, and the microscopic slide. So first, I will be immersing the tissue specimen in an isotonic solution. So once the specimen has been immersed in the isotonic solution, it will now be subjected to the isotonic solution. So next, using a dissecting needle, I will dissect the tissue specimen. So I will be doing this until the tissue has spread out or has unfolded. After which, I will be placing the tissue specimen on a microscopic slide for microscopic examination. So that is all for teasing method of fresh tissue preparation. I will be performing the squashing method of fresh tissue preparation. So squashed preparations can be performed simply by crushing a small piece of tissue between two microscopic slides. It is important to note that the tissue specimen must not be less than 1 millimeter in diameter. So first, I will be placing my tissue specimen on a microscopic slide. Then I will cover it with another microscopic slide. Then I would crush the tissue specimen so that it will be flat. So this is now a squashed preparation of a tissue specimen. I will now proceed with the demonstration of the different techniques of smearing. Smearing is a method of choice for examining sediments and is used for cytological examinations such as in diagnosing cancer. So first, I will be showing you the materials that I will be using today. So this is my specimen of choice, which is a pig's blood, my applicator stick, and my microscopic slide. So the first technique that I will be demonstrating is the streaking method. Streaking is a procedure in which a selected specimen is applied gently and rapidly throughout the slide in a zigzag manner in order to obtain a relatively uniform distribution. So first, I will pour a small amount of the specimen, the pig's blood, on one end of the clean glass slide. Then, in a zigzag manner, I will streak the specimen up until the whole length of the slide. So this is now streaking. The next technique that I will be demonstrating is spreading. It is a procedure in which a portion of a specimen is spread gently into a moderately thick film by teasing the strands apart using an applicator stick. It is recommended for smear preparations of bronchial aspirates, fresh sputum, and thick mucoid secretions. So the materials that I will be using are the specimen, the applicator stick, and the microscopic slide. So first, I will be transferring a small amount of the specimen on one end of the clean glass slide. Next, I will be spreading the specimen in a straight line up until the remaining length of the microscopic slide. So this is now spreading. The next method that I will be demonstrating is called the pull-apart method. It is a procedure in which the specimen is dispersed evenly across the surfaces of two slides, and the slides will be pulled apart with a single uninterrupted motion. It is used for bone marrow aspirates. So here are my materials, my specimen, and two clean microscopic glass slides. So first, I will transfer one drop of a specimen in one end of a clean glass slide. And then I will cover it with another glass slide in order to allow the specimen to be spread evenly across the surfaces of the two glass slides. And then with a single uninterrupted motion, I will pull the slide apart. So this is now the pull apart method. The last technique that I will be demonstrating is called touch or impression smear. It is commonly known as imprint. So in this procedure, I will simply touch the tissue onto a clean glass slide. The most commonly used specimen is cord bone. However, for this activity, I will be using an animal liver. So first, I will pick up my specimen. Then, I will allow it to come in contact with a clean glass slide. This allows the cells to come in contact directly with the slide. So this is now imprint.
Hello, I am Maria Angela Dumagonot and I will be demonstrating a gross examination of an organ obtained from a full-grown chicken. For the purpose of this demonstration, I will remove my mask to have a clear voice. The materials are to be used in this activity are the following. First, we have a sharp knife for cutting the specimen. Next, we have a clean chopping board where the whole procedure will be done. And a clear ruler with graduations to have a precise measurement. And lastly, we have our specimen of choice, which is a liver of a full-grown chicken. We will start the gross examination by identifying the specimen of choice. As you can see, this is the liver obtained from a full-grown chicken. Its color is tan red to brown, its shape is wedge, and its consistency is glistening and it is soft. Since the liver has two lobes, let's start measuring it in the right lobe. The length of the right lobe is 7 centimeters. The width of the right lobe is 4.5 centimeters. And the height measures around 0.8 centimeters. Now let's move on to the left lobe. The length of the left lobe is 5 centimeters. The width of the left lobe is 4.5 centimeters. And the height measures around 0.7 centimeters. As of this moment, I will be performing a cross-section cut to obtain a representative tissue for thorough examination. The sectioning reveals a tan red to brown mucosa with flat formation and tissue fluid.
Fixation is a process which involves fixing or preserving fresh tissue for examination. This is the first and most critical step in histotechnology. It aims to preserve tissue nearest to its living state, to prevent bacterial growth in the tissue, to prevent autolysis, and to have better optical quality of the cells. So, for the first step, put the cut specimen inside the modified tissue cassette. Then, seal it with an elastic band. Next is label the tissue cassette with the name, age, gender, and code of the patient. So for the second step, after the specimen is cut and placed in a modified tissue cassette, I am going to put the specimen inside the beaker filled with a fixative formalin. And lastly, cover it with a foil. And leave it for 18 to 24 hours.
After we are done with our fixation, we will now proceed to dehydration. This is to remove excess water from our tissue samples. So we will immersing our tissue samples into ascending concentration of alcohol. This is in order to prevent major damages to intracellular membranes of our tissue samples and also to minimize the shrinkage of our tissue. So let us now proceed to the procedure. So first, we will transfer our tissue samples into the lowest concentration of alcohol that we are using, which is the 70% ethanol. And we will gonna leave it for several minutes. So after several minutes, we will now proceed and transfer our tissue samples into much higher concentration of alcohol, which is the 95% ethanol. And then let's cover again our container and leave it for several minutes. So after several minutes again, we will transfer our tissue samples into the absolute alcohol, which is the 100% ethanol. Cover it again with foil and leave it for several minutes until it is done and complete.
I am Mark Albert S. Magdabon, and I will be now demonstrating the decalcification process. So first of all, we must know that we only do decalcification if the tissue has calcium and is hard. So in order for the tissue to be softened up for the microtome, we need to do decalcification process. And without further ado, let us start the decalcification. So for this process, we're going to use the decalcifying agent called the nitric acid solution, which is a mixture of 100 ml distilled water and 10 ml nitric acid. So first, we need to get our tissue sample. And here we have a portion of a chicken bone, which has calcium and it is too hard for the microtome. So we need to do the decalcifying process. So first, we need to put it in the gauze and loosely secure it. Once the sample is secured, we now submerge it in the decalcifying agent. And after it is submerged, we must now wait for a certain amount of time for the decalcification process to occur. And it all depends on the decalcifying agent used. In this case, we use nitric acid solution, So we must wait 12 to 24 hours for it to fully decalcify. That will be all. Thank you.
Good day everyone. Today I am going to demonstrate clearing of tissue samples. So for this demonstration, we are going to use xylene as our clearing agent. So to start, we have prepared 3 volumes of xylene, and at certain time intervals, we are going to immerse our tissue in each of the volume in order to ensure the removal of our dehydrating agent. So to begin, let us immerse our tissue into our first volume. Okay, after immersing the tissue, we have to seal it. So after sealing the tissue, we are going to let it sit for 20 minutes in order to facilitate the removal of the dehydrating agent. So after 20 minutes, we will now replace our clearing agent with a new one. So let's take our tissue. Okay. And put it in our second volume of xylene. So again, we have to seal it. And still, we are going to let it sit for 20 minutes to continue the removal of the dehydrating agent. So after 20 minutes, we are now going to take our tissue from the container and replace our clearing agent. So let's take our tissue, okay, and put it in our final volume of xylene. Okay, then let us seal it. So to ensure the complete removal of our dehydrating agent, we are going to let this sit for 45 minutes. So after 45 minutes have passed, we can now take our tissue from the clearing agent and place it on a paper towel for it to dry. So this tissue can now proceed to the next step of tissue processing.